Hello and welcome to this XP Live webinar. My name is David Fortune and I'm Director of Innovation here at XP Solutions. More and more of us want to apply the principles of water-sensitive urban design, or WSUD, and this coincides with best practice in conceptual design of SUDs. In this webinar, we will demonstrate a workflow that gives an effective, quantifiable treatment train approach to stormwater management. You will see how to apply XP drainage to a site in order to compare pre- and post-development flows and water quality. And this is one of the key concepts in WSUD and SUDs. We'll be using our Getting Started tutorial dataset for this demonstration, and the reason is that you'll be able to repeat the workflow for yourself later on at your own leisure. I want to introduce today's presenter. It's Jessica Jeffries. Now, Jessica has over 7 years of experience with XP Solutions, and she specializes in technical support, training, and product specification. She's currently Products Manager in Australia, but many of you will know her from when she was based in our UK offices. I'm going to cover a short bit of introduction now before we move on to the demonstration itself. It doesn't really matter whether you call it WSUD, SUDs, LID, green infrastructure, blue-green corridors. I think we all recognize that this is a huge change to the way that we manage rainwater. And increasingly, this change is being driven less and less by legislation, but much more by the way that we value rainwater these days and our desire to use it to improve our urban environment. Some of the benefits of WSUD, or SUDs that we're looking for, are to retain pollutants on site, to recharge groundwater and streams, evapotranspiration, which even in the cooler weather that we tend to get is important to reduce urban heating, and particularly to make attractive use of water to increase the biodiversity we're getting into our urban areas. And of course there's other benefits such as flushing to reduce power and chemical use. Now, to do all this, it involves quite a change to the way that we design drainage. We want to now take account of the natural flows on site. Particularly important is to compare pre-development, post-development flows and water quality, and that's the main subject of today's webinar. But also today you'll see a bit of storage, pollution removal at source, using the treatment train approach so that we see the SUDs or WSUD distributed right across the site. And we always keep in mind that drainage design needs to be affordable, robust, maintainable. And we feel that you can use XP drainage to help make sure that's true. So we want you to be creative in the use of rainwater on the site. We want you to be able to improve quality of life for everybody in our urban areas using that stormwater. This does, we're absolutely sure all of us, increase the value of developments, and that's going to be more and more important in the future. XP drainage allows quite a variety of stormwater controls in the treatment train: green roofs, swales, ponds. I won't read them all out, but they should all be there, all the ones you want to use. If you start to find stormwater controls that you do want to use not there, just talk to us and we can always add them in the future. Just a brief overview of the workflow that Jessica's going to demonstrate today. We're going to start with a look at pre-development stormwater runoff and pollutant wash-off, because XP drainage covers both flows and pollutants. We've got some handy calculators for estimating volumes needed for flow control and for pollution management, and Jessica will demonstrate one of those. And then the all-important comparison of pre- and post-development runoff. She'll show you how it's easy to locate SUDs on site and connect them up as a treatment train or a stormwater treatment system. And then we're going to compare the results for pre and post development for the design that's been created. How has that changed what flows off the site? Of course, design or conceptual design or setting up a water treatment train, you never really get it right first time. The whole aim of XPDRAINAGE is that you can use the simulation in there to iterate towards the result that you want. So we'll show you how to modify the design, rerun, and compare, just to check that you're moving in the right direction. That's all I wanted to say as introduction. I'm going to hand over to Jessica now, and we'll get straight into the software.
Thank you very much, David. Yeah, I'm very excited to be showing you the software here today. And what I wanted to do to start with was actually show you what we're aiming to have at the end of this session in the software, which is a typical scenario or site where we have a greenfield location that's been approved for development. We've analysed the pre-development site and surface, chosen suitable SUDs, and set up a treatment train to deal with water quantity and quality and create essentially a water-sensitive urban design. You can see here I've got the software open, XPDRAINAGE open, and on the left-hand side we have what we call the tree view, and this allows us to see the objects on the site and interact with them in a similar way to layers work for those of you that might be familiar with GIS and other software. Before we actually design this, I want to just go to the phase management section of the tree view, and here we can see that we have two phases, a pre-development phase and a post-development phase. So our pre-development phase is very simple. It is just one area. We're analysing the flows from that area. Our post-development phase is essentially our treatment train of SUDs. We've connected up areas with stormwater controls. We've got outlets set up. And so we can easily switch between these two phases using our tree view, and this is the focus of today, to show you how to do this comparison. Though we're showing this functionality for pre and post development phases, it can also be used to compare two or more mitigation scenarios. However, for this example, we've been able to compare the flows, the volumes, and the pollutant loads between the pre and post development, and quantify if the approach we have taken is an effective treatment train. So we'll come back and look at results at the end, but now I'll show you how easy this is to build in the software. So here I've got the software as it is when you open it up, and what we're going to do is use the ribbon along the top here to actually lead us through the natural workflow as a guide to help us build our design. And the first thing we want to do is bring in site data. So all the things that we associate with site data, the background data, surfaces, CAD files, GIS files, images, and so on, are listed under the site ribbon. A lot of these functions are also duplicated then either in the tree view or in the toolbox. So as you become more familiar with the software, you'll find your own way to use it. So we're going to start with our pre-development phase. So in our phase management section of the tree view, we're going to rename this phase to pre-development. And then we'll start by loading in an image. And this image that we're loading in, our greenfield site, is georeference. It's a JPEG that has a world file with it. So we're located in the correct place. And I'll just zoom in. This is the area we're actually focusing on for development here. Next, I'm going to load in some surface data, and there's a couple of reasons for doing this. We can use this in our tool, our Deluge tool, which we'll come to in a minute, to analyze where the flows go on site. And it's also very useful if we want to set up our stormwater controls using the data from that surface, so set our cover levels and ground levels and so on. So I've just opened this CSV file here, and we have a universal importer which you'll see in a few places in the software to allow us to load any number of different formats. So all we have to do when we load this data is actually just select what the data format is in the file, just simple XYZ data in this case, and when we click OK, it builds a surface for us and just prompts us to save that surface. So then that surface is loaded in. We don't have any of the surface layers turned on visually, so if we turn on the triangles, we can actually get an idea of how dense that surface data is. Now we've loaded in the surface, we can use the first of our design tools, which is the Deluge functionality. And I can access this by right-clicking on the Deluge layer and just selecting Go. And I'm just going to change this analysis so that I run it for a little more time, just for 15 minutes. And what we're doing here, we're just dumping water on the surface. We're intending to show where the main flow paths and the main ponding areas exist so that we can choose sensible locations for our stormwater controls. I'm sure you're all thinking, wouldn't this be a really nice scenario? Well, we're going to hopefully help you to bring stormwater right to the front of the design. So I'll turn off the surface, which will allow us to see in a bit more detail what's going on, and we can identify from these results that the flows are mainly flowing down towards we can just see the corner of the lake there in this scenario. These darker areas are showing us where the ponding locations are, so it would be sensible to consider those when we lay out the drainage on the site. I can right click on the Deluge layer and I can actually just view what do these what colors have been used, have they been set up. I can change the setup here. So at the moment we're restricting the minimum to 50 millimeters, so any water below 5 centimeters is not shown, but we could choose one of the default color ramps if we wanted, or insert pegs along here as well. Other aspects of the setup may include altering the units. This can be accessed through the File Preferences menu, as well as a number of other customization options. We're happy with the units in this case, so we'll leave those as they are. The next thing we need to consider as we work along our ribbon is the rainfall. So what rainfall do we want to use for analysis? And we allow you to set up rainfall that can be reused for different jobs in a rainfall library. So we want to input some rainfall data. At the moment we don't have any rainfall data in the rainfall manager. So we have a number of options. We have a number of design storm options for various locations around the world, including FSR and FEH for the UK. And we also have a user-defined design storm option, which would allow us to set up design storms for anywhere in the world. On this occasion, we're just going to enter one storm, one rainfall record that we actually have in an Excel spreadsheet. So I'll add a new rainfall record, and this allows you to pretty much put in any kind of rainfall. Just that could be one individual storm, or it might be a long rainfall record. So what we can do is add a new rainfall record and then open our Excel file that contains our rainfall data. And that universal importer again just pops up so that we can set up exactly what format the data's in, whether it's an intensity or a depth, in this case a depth, and then it will read that data in for us. We can switch to the graph to check that's what we're expecting, and we can actually then change it to show us that graph as an intensity. I'll say OK there, and we want to tick this rainfall to use. We want to use this in our design today, and we'll increase the runtime to 360 minutes. It's quite a large site, so we need to allow enough time for the water to drain down. We could then continue to add further storms if we wanted to, but for now we'll just run with this one storm. In the little tree view on the left hand side here, I have the option to rename this, so I'm going to name this after the location of the site, which is Yarralumla, and then just close that form, and that rainfall is now stored for us to use within our design. Now I can go to the option to add pollutants stepping through my ribbon workflow here. And if I click on pollutant data, we can see at the moment there's no pollutants set up for this site. So we're going to add some new pollutants. I'm going to add 3 pollutants, and we're going to analyze total suspended solids, total phosphorus, and total nitrogen, which are fairly typical pollutants to analyze. So that enters a lot of the data that we need in order to then actually start adding areas and analyzing our site. I'll turn off the Deluge now, and all we have to do now is move. We'll skip over the design tools until the post-development site, move to the build menu. And again, this gives us clues as to what we might want to do on the site. We might want to add inflows, inlets, stormwater controls, outlets, or connections. These functions are mostly duplicated on the toolbox. So again, as we become more familiar with the software, we can choose how we move around the software, either using the ribbon or the toolbox. If we go back to the build here and add an inflow area, what it does is our cursor changes so that we can actually just draw the area on the site, and this, our site boundary is roughly this field here, which we'll see when we actually load in our CAD file shortly. So we draw the area and then open that up so that it can be edited. And we can see the area has been automatically calculated because that image that we loaded in was georeferenced, so it actually had coordinates contained within it. We have a number of runoff methods already built into the software, and we're adding more and more all the time. You'll soon see some UK-specific runoff methods in there for FSR, FEH, and REFH unit hydrographs. So we're updating this all the time for different regions. For now, we'll stick with a very simple analysis method using the time of concentration, and just change that volumetric runoff coefficient to represent that we'll get about 35% runoff from this rural area, and set the time of concentration to 33 minutes. We can also now put in the pollution data for this area. So we enter a concentration as to how much of each pollutant is coming off the site, the concentration in the water. That's in milligrams per litre. We can edit the units again if we prefer to enter this in a different unit. So then we click OK, and that's as much as we need to actually analyze the pre-development condition. So you can see it's taken just a few minutes, and we've been able to set that up. So having completed the build as such for our pre-development, we can go to the analysis ribbon and enter in the analysis criteria. And all we really need to do is pick the rainfall here. So this shows us all the rainfall that's available in our rainfall library. In this case, we've only set up one rainfall record. There's a number of settings on the right-hand side here that we can adjust. We'll stick with the default options here, click OK, and then we have the option to validate our design to see if there's any missing data. Obviously, we've only put in a limited amount for the pre-development site, but this is very useful if you have a large site. It will actually identify exactly where there's missing data, take you straight to that location so you can put that in. So we can hit go, analyze that, and it tells us how much volume we're generating from that area and what our maximum flow is from that area as well. We can look at the graph to see our inflow and also look at the pollution totals, the total load we actually receive from that site. Now this data on its own is useful, but it's nowhere near as useful as when we start to compare this against our post-development conditions. So we'll move straight into the post-development phase now, and some of our data excuse me, is overlapping. So what we can do is use the tool that we have available to duplicate our existing phase. That's available via the right click, and if I duplicate that phase, it takes all the data from the pre-development phase and duplicates it, and I can now rename this. I need to make sure that my post-development phase is selected so that I work on the right one. We want to just clear that inflow area. We're going to replace it with the actual areas on the site, and we're going to update the image as well, so we'll clear that one. We have still got the surface data in there, although it looks like it's blank. So the first thing I'll do is update the image with our post-development image. And we can see now, if we zoom into this area, now we've got the layout of the houses. We've also got a CAD file that we can import showing the development area. And we could use data from this CAD file to actually populate our inflow areas, to lay out the space that our stormwater controls will take up, to populate surface data. In this case, we want to use it as background data that we can snap to. So when we zoom back into this location, this gives us an idea how we can split up the catchment into different areas, and we can use the snap tool in order to do that. So essentially what we've done is we've gone back to the start of our workflow for the pre-development phase. So we've loaded in our site data. We already have rainfall and pollutants set up. So now we can use our design tools. And these design tools are really useful. We've run the Deluge, so I'll move straight to the volume calculators. And what these do is give you indications of where you can start with your design. It's often difficult to know, okay, we know from our pre-development condition what volume and flow we need to reduce the runoff to, but where do we start? How much volume of storage do we need? How much water might we need to deal with the pollutants that are coming off our site? So with the volume calculators, we can do two estimates, one for storage, one for quantity, and one for quality. I'll untick assume inflow from design. This would allow you, if you had drawn your areas in the post-development condition, to actually use the runoff from those areas. We're just going to put in the site area, which is 10.6 hectares. We'll say that for our post-development condition, we'll have a runoff coefficient of 0.75. Our discharge rate, we want to get back to that pre-development discharge rate, which was around 1200 litres per second, and will allow for some infiltration on the site. We have some of the site available that we can use for infiltration, but we're not necessarily going to do that across the whole site. And then we'll select the rainfall again. So this is just one storm. If we were using design storms, we could essentially run this for multiple storms. And then you can see we get an estimate of how much storage we're going to need, both with and without infiltration. And obviously we have less storage if we are able to infiltrate into the ground. On the water quality calculator, it's even easier to use. All we would have to do is enter the depth of rainfall that we would want to treat, whatever that might be, put in our total site again, and then decide how much of that runoff, what percentage of that runoff do we actually want to treat. If we just leave it as 100%, it tells us we would need a wet pond or similar storage structure or stormwater control with around 2,000 meters cubed of water in it to actually deal with those first flush pollutants. Okay, so now we've got our site data loaded in, we've used our design tools to give us an idea where to start, and we go on to the build menu and the build section of the workflow again. So the first thing we would want to do is add our inflow areas. So again, we can use the ribbon or the toolbox in order to do that. I'm going to add one of the areas on the right hand side of the site here. I'm not going to be too accurate about snapping to the CAD file, but obviously you can be as accurate as you need to, and that snap tool is just available in the plan view menu there. So that puts in an area again very much like the runoff for our pre-development site. We can enter in the time of concentration, and we can also enter in the pollution, and we're likely to see more pollution coming off our post-development site, than our pre-development site. And this will allow us to then compare how good our design is when we come to the end of the design. So just to have a little look at our stormwater controls here, you can see we've got a whole list available. David talked about some of them. Each one has a slightly different setup, and we'll spend some time in some more webinars going into detail about some of these stormwater controls and what you might need to put in to set them up. We're going to just pick a swale to show you today, and I'm going to drop that onto the site here. So we're going to have this area draining into a swale, and again I can outline this swale, and that'll just help me when I come to visualize the site, and also when I'm entering the data. When I open the swale form, what it's done is it's given me what my exceedance or cover level might be. It's automatically assumed a length from the drawing. I can update that length if I need to. It's also put in a base width, and then we can add the rest of the data in here. So for the swale, I'm going to enter a freeboard of 150 millimeters. This means it will report any water that comes within 150 mils of the exceedance level. I'm going to put in a slope. I'm actually going to change the base width. It's a bit bigger than I might have liked. And then I'm going to put in the base of the swale around about 700 or 800 millimeters below the exceedance level there. And the side slopes of the swale at a typical sort of 1 in 4 rate. It's automatically calculated the top width of my swale based on that side slope. So it's a pretty big swale, 10 meters wide, obviously you can design these however you need. I'm not going to have a trench underneath this swale, so this is going to be a typical grass swale, so I don't need to enter a filtration rate from the base of that swale into the trench. However, on the Advanced tab, I could add infiltration just from that swale into the ground, and I'm going to do that for the base of the swale and just allow this swale to have some infiltration. If we were running a longer term simulation, we might want to allow for an interception volume and evapotranspiration. I'll leave these blank for now. The good thing about this advanced setting on the form is that if you're doing something very simple, you don't need to go into the details of this data. Here we can allow for the fact that the water will be slowed up in the swale. So we can actually enter in a retention coefficient, and then we can calculate how long it might take for the water to flow through that swale. And based on the Manning's N I've just entered, the water might take around 17 or 18 minutes, so we're going to have the water held up in the swale. We can also now allow for the pollution removal for this swale, and we have two methods in the software for allowing for pollution removal depending where you're working and what level of detail you want to go to. And that's a percentage removal method or a first order decay method. With the percentage removal method, it's very simple. We can just enter in those percentage removals, but we can still use the option if we want to say, I'm not actually going to allow these pollutants to go below a certain concentration. Whatever happens, I don't believe my swale can ever remove the total suspended solids below 20 milligrams per litre, for example, and similarly for the other pollutants. We don't have to use that, but we can if we want to. So having set up just one area, one stormwater control, what we need to do now is connect them up. And we have a range of connection types that we can use. These connections can allow for a delay in the flow and attenuation, or they can just simply transfer the flow with no delay. And it's very easy just to draw on the plan there and connect those up. Once we've connected those up, if this was just a design with one area and one stormwater control, we could then add an outlet to our swale and set up that orifice so that we were holding the water back in the swale. We can open these in at the same time, so we can copy and paste data, and you have access to the calculators that help you to size these outlets as well. So if we knew what our ideal depth was in the swale, say we wanted to ideally have 0.5 meter of water and limit this swale to 50 litres per second, we could actually size that orifice there. Now obviously we don't want to build this whole model up for you during the webinar, but these tutorial files will be available so you can play around with this and see how you go with the software. Technically we can now analyze this. I think we have actually put enough data in, but what I'd like to do is go back to our original design and look into a bit more detail about the pre and post development comparison. And if we go to our results tab, so from our analysis we go to our results, the first thing we get in this post-development phase is actually information about each stormwater control. So how is it behaving? We've got a range in this model: bioretention areas, swales, porous paving, and finally a wetland at the end of the system. And you can see the report here gives you a lot of information about levels and depths. It also tells you how much water is infiltrated in each of these systems and the outflow. really important column is this final one, and that's the status, and this gives us just at a glance an idea how these systems are behaving. The OK status means that the water level in our system is below that freeboard, that level that we suggested should indicate a flood risk. We've got 2 of our systems that show a flood risk. So we could now go back, iterate our design very quickly, rerun the analysis. What we really don't want to see here is flood, because that means water is above our cover level or exceedance level and flowing over the ground. So that's one of our results. We can also, if we have multiple storms, look at all the storms for one of our individual stormwater controls. If we select any of our elements in the system, whether that's an outlet or a stormwater control itself, we can look at individual results and we can see what's actually happening time step by time step. We can look at the graphs for that individual stormwater control and the pollution removal that's happening within that. But where we get into the really powerful outputs is when we look at the phases report. And this is a flexible report builder that allows you to compare different phases as well as add additional information from individual phases. So we could go to the post-development phase, for example, select our storm, select the pollutants, and just look at a summary of the inflow, and that will generate a report for us for that particular stormwater control. However, what I really want to focus on is the comparison. This is where we have some really useful data. So we've got 2 phases, 1 storm, all 3 pollutants. We could now say, okay, what data are we really interested in? Well, I'm not that interested in how much water is infiltrated, how much water has flooded, and how much water is held in the system, but I do really want to know about the inflow and the outflow. And I want to know about the pollution, and I want to see the graphs. And if I update this preview now, I'll just pause so the software can catch up. Then we can very quickly see what's happening on this site. So for our pre-development, we had a maximum inflow of 1,200 and a total inflow volume of 3,100 meters cubed. For the post-development, that maximum inflow obviously increased dramatically, as did the volume. But by cleverly setting up our treatment train, we've managed to reduce the maximum outflow and the total outflow volume to below the pre-development conditions. So we can say, yep, tick, for quantity, we've achieved what we need to achieve. For water quality, we can do the same. We can make this comparison. So for pre-development, we have 71 kilograms of total suspended solids coming in off this site. And for our post-development, we've got 64 kilograms, so we've reduced it. If we look at phosphorus at the load in for pre-development and the load out for post-development, we can see we've got a reduction there. And for nitrogen, if we look at the load in for pre-development and the load out for post-development, we can see the reduction. The graphs are really useful just so we can see what's going on. We've got both the pre and post-development on the same graph here. So we can see our post-development scenario compared against that pre-development. If you look at the red for the pre-development inflow compared to the purple for the post-development, for example, it's a very different result happening there. So this report can be exported as well. We can export it to a PDF format or to an Excel file. So if we want to reformat it, we can do that outside the software. I won't have time today to go into a lot of other detail about building templates and so on. We'll show that in a future webinar, but it's worth just mentioning that you can actually then add the items that we've developed into a template builder and reuse these over and over again. So that'll be the focus of a future webinar. But today we really wanted to focus on the pre and post development comparison and how you can actually quantify what you've done in your design for both water quality and water quantity. Thank you very much for joining us today for this XP Drainage webinar, and we'll speak to you soon.